Okay, folks, for problem number one, the first thing that we want to do when we're doing a transformation on a function is to identify the parent function. So we discussed those in class. This one in particular is the cube function because we see that we've got a power raised, or our power is 3 here, so we've got our x raised to the third power. So our parent is going to be y is equal to x to the third. Now, the points that we establish for this function right here, which are going to be down here, those are really, they're just nice, easy points that, that are going to graph in a nice range over here. And so what I would do is write down for each of the parent functions, write down the points that you were given in class. And so for the x values to the third power, the easiest ones are probably from -2 to +2 for x. And then what we need to do is figure out what the associated y values are for each of those. Let's put this one in the box. So how do we figure out the y values? Well, we're just going to take these x values and cube them. So the first one's going to be -2 multiplied by itself 3 times. So -2 times -2 is +4, times another -2 is -8. -1 multiplied together 3 times gives me a -1. 0 is going to give me 0, 1, and 8. So the reason that these are chosen is because they're just nice integer values that we're able to put on that curve pretty easily. The next thing we're going to do is we're going to identify our transformations. So the transformations are going to come from looking at our function. Now your instructor has got you guys set up. There's lots of ways of doing this. Your instructor has you guys set up to do the following order. So you're going to check for vertical stretches, shrinks, and reflections. So anything vertical is done after the parent function has a chance to act in the x. So I like to think about it like outside of the parentheses or outside of the function symbol, like a square root symbol. Okay, and you'll see that on the next one. But so the things that are happening outside are this negative right here and this 1 right here. The 2 is happening on the inside. Of course, the 3 is the parent. So we've already used this 3 part here, so we don't have to worry about that anymore. So the negative now, okay, the first thing that we're going to do, his order is, and you want to stick to this order so that you make sure that you're moving these correctly. The order is going to be to work with these reflections, okay, on the outside first. So anything that happens outside of this, whatever is being cubed, so anything in here is inside, these guys are outside. Outside is always a horizontal movement. So everything outside is horizontal. Inside is, oh, I said that wrong. Everything on the outside is vertical. Oh my gosh. Okay. I would remake this video, but it'll take too long, so you just have to bear with me. Everything on the outside is vertical, up and down. Okay, everything on the inside is horizontal. Okay, so this guy on the outside is going to be an up-down, a vertical issue. So this negative here and this 1 here are both going to impact our y values or our vertical movement. And when you're working on either the inside or the outside, when you multiply, so okay, when you add or subtract, that'll always be a horizontal or a vertical translation. So that's going to be like a sliding of the curve up, down, left or right. So I like to think about these as like magnets on the refrigerator. If you take a magnet on the refrigerator and you slide it, okay, up, down, left, right, doesn't matter. It keeps the same shape. The magnet's still the magnet. It's just sliding. And so that's what happens. That sliding is the transformation when you add or subtract. So both this 2 and this 1 are both going to be slides of our graph. So they're going to take our whole graph and just slide it. So we call those translations. I like to think about them as like a sliding. If we multiply or divide, that's going to be a stretching or a shrinking of the graph. Now, you don't have any of those on these questions, but that would be like if you're going to stretch or shrink. With the exception of negatives. If you multiply or divide by a negative number, inside or outside, it's going to be a reflection. So if it's on the outside, it'll be a reflection vertically. So it'll be an up-down reflection. So that's what this guy is right here. So because this negative is not inside the parentheses next to the x, it's on the outside, it's going to be a vertical reflection. So what's going to happen is every point is going to reflect vertically along the y-axis. What I mean by that is like our point -2, -8. Let's get that into the viewing range here. So -2, -8, that was on the original x cubed. But now when we put the negative into it, what it's going to do is it's going to take this point and it's going to reflect it vertically. When we reflect vertically, we reflect along the x-axis, so up, down. So this point was at a -8, it's now going to move up to be a +8. So this point here is going to reflect up to here based on this negative here. There, we can see it. So based on this negative. So what we're going to do is we're going to keep the x values all the same, but our y values are all going to change sign. So this is going to be -2, +8. This would be a -1, +1. So everything is reflecting. So what's negative becomes positive, and what's positive is going to become negative. And these are for our y values, again, because it's on the outside of our function. Okay, so let me just zoom out just a little bit here for you guys. There you go. Okay, I'm also going to erase these because I've made my point now with them, and they're not on the final graph. Okay, the next thing that that you guys are going to do is you're going to still work vertical, but now you're going to work on your shifting, which is your translation or your slide. Okay, so first we deal with the multiplication on the outside, then we deal with the addition and subtraction. On the inside, everything's opposite. We'll deal with the addition and subtraction first, then we'll deal with the multiplication and division. Okay, and there isn't any here, so you don't have to worry about it. So the next thing to worry about, we've already got done with this. So we've used the 3, we used the negative, now let's use the 1. So that 1 is on the outside, so it's going to be a vertical up-down issue. It's adding or subtracting, so it's going to slide everything. And on the outside, everything behaves exactly like you think it would. So if it's plus, it's going to go up. If it's minus, it's going to go down. The inside is where everything is opposite. So on the inside, if you see plus, you actually move to the left. If you see minus, you actually move to the right. If you multiply by 2 on the outside, you get bigger. If you multiply by 2 on the inside, you actually compress. You get smaller. So everything on the inside is the opposite. Everything on the outside is the same. So let's just put that down here. So everything on the outside is the same. Everything on the inside is opposite. Okay. Good. So, where are we at? Well, we're going to add 1 to all of the y values. So we have a vertical slide, a vertical shift, or a vertical translation of up by 1. Okay. So all of these points, we're just going to add 1 to all the y values because they're all going to shift up by 1. So -2, 9, -1, 2, 0, 1, 1, 0, and then 2, -7. Now we're done working with the outside. So we've dealt with this, we've dealt with this. Now we're going to deal with the inside. So the inside, we're going to deal with the plus minus stuff first, and then we would deal with if there's something out in front of the x. So the plus minus stuff first here we've got a plus 2. So we're adding or subtracting, so it's going to be a literal shift or slide of our function. All of our points are going to slide. Since it's on the inside, it's horizontal, so we're all going to slide left or right. And since it's a positive 2 and it's on the inside, we're doing opposite. So that's going to slide to the left by 2. So we are going to do a horizontal translation left by 2. So this is going to be -4, 9. Let's see here. -3, 2. -2, 1, -3. Oops, sorry. -1. Something wasn't looking right there. And then 0, -7. Okay, so we've got all these guys. Now, how do you know if you did it right at the end? Okay, so pretty easy. And let's just check, because maybe I goofed something up. That's very possible. So what we're going to do to check is we're just going to grab one of these points. We can grab whatever we want. I'll grab this one, the -2. +1. And what I'm going to do is I'm just going to plug that in. The -2 is going to get plugged in for the x value right here in this function. And what we should get out +1 if we did everything right. So what we're doing is we're testing f at -2. So that'll be negative times -2 plus 2 cubed plus 1. Oh, this is going to be easy. So again, now let's put an equal sign here. So -2 plus 2 is 0. 0 cubed is, well, 0. -0 is still, well, just 0. Plus 1, sure enough, is equal to 1. So that's what we thought we'd get out. When we plug in -2, we thought we'd get out 1. Now we can try it with another one, like let's say we take -4. Okay, so -4, we should get out 9. Well, -4 plus 2 is -2. Okay, so -2 cubed is -8. -8 times a -1 is +8. +8 plus 1 is +9. So it looks like we've got them all correct there. Okay, so you can go ahead and you should be able to check each of these on your test very quickly. You don't have to do all of them. You just check 1 or 2 of them and just make sure that they do line up. If they don't line up, you did something wrong. Okay, and so that's a big indicator that you should go back and check your answer. Yeah, okay, so hopefully that makes sense. Then we'll go ahead and we'll, let's just do it right now, as long as we're... Oh, and then it looked, I forgot. I think you need to graph those guys as well. So we'll just plot the points on here. I'll do that real quick for you. So -4 up 9, -3 up 2, -2 up 1, -1, 0, and 0 down 7. So hang on, I gotta rotate this a little bit here. Okay, it's not perfect, but it's not perfect because like I crossed here. It should be just a little bit more down this way, but you get the general idea. Okay, so this should be the graph of this guy right here. If you go ahead and you plot it out on like Desmos or whatever else. Okay, let's try the next one. So same idea. We're going to deal with the outside stuff first. And so for the outside here, there's nothing multiplying out front. So we're going to deal with this -5. That'll be our first transformation. The parent curve for this is the square root. So y is equal to the square root of x. That's our parent graph. Some easy points on the parent well, we can't do any negative values for x, right? So we're not allowed to plug in, working in the real number, with the real numbers, we're not allowed to plug a negative in here. So it's just not defined. So we can start out with 0. When we take the square root of 0, we get 0. 1 is a good one, because the square root of 1 is just 1. That's a nice integer. 2 and 3 don't work out nice, because the square root of 2 is an irrational number, and so is the square root of 3. They're just numbers that just aren't pretty to write out. So the next nice one is 4, because the square root of 4 is positive 2. And then really the next one out there is 9. And the square root of 9 is 3. Okay. So these are our nice guys that we're going to go ahead and we're going to move around. So we've got two transformations here. One's the -5, the other one's the 4. They're both adding or subtracting, so they're both going to be slides of this function. So the first one on the outside is -5. So that is a horizontal, or sorry, gosh, that's a vertical translation down, I'll say down 5. That might be there. That's a better 5. The other one was pretty bad. Okay, so everything's going to move down 5. So all we're going to do, we're not going to change the x values. Just going to change all the y values. So they're all going to go down 5. So -5, -4, -3, -2. The function that we just graphed here, by the way, is the square root of x minus 5. Okay, so without the 2 in it. So this is what we just plotted. So again, if you take any of these numbers and plug them in, like if you take 4, plug it in, the square root of 4 is 2. 2 minus 5 is a -3. The next transformation is this +4. Again, everything on the inside is the opposite, so we're going to move left. So this is a horizontal translation left by 4. So we're going to subtract 4 from each of these x values. So -4, -5, -3, 0. And it looks like 5. Just leave all of our y values the same. Okay, now again, we should be able to take any of these and plug them in, and they should work here. Like for example, if I plug in 0, well, let's not plug in 0. Well, okay. So if I plug in 0, it'd be 0 plus 4, which is 4. The square root of 4 is 2. 2 minus 5 is -3. If I plug in 5, 5 plus 4 is 9. Square root of 9 is 3. 3 minus 5 is -2. And so now we just have to go ahead and plot those guys out. So let's see here. We're at -4, way down here. -5, -3. At -4, at 0. We're at -3. And way over here at 5, we're at -2. And so there's our curve. So this right here is what this guy looks like. Okay, so hopefully that makes sense. Just follow your steps. You do the outside first. You're going to do the multiplication first, then the addition and subtraction. Then when you go to the inside, addition and subtraction first, and then multiplication and division. Okay.